Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at implementing tasks that promote reasoning and problem solving. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Please join me in welcoming our two panelists for tonight, Jill Goff and Jennifer Wilson. Jill is the Director of Teaching and Learning at the Trinity School in Atlanta, with over 30 years of experience as a math educator and leader, including her role as a T-Cube instructor. Jill brings her expertise in developing teachers become more effective in their practice. Amongst her many awards, Jill is a presidential awardee for excellence in math and science teaching and an Teacher for the Future for the National Association of Independent Schools. Jill, thanks so much for joining us tonight.
Oh, I'm glad to be here. Thanks.
And Jennifer is a core advocate and nationally board certified teacher, and she has most recently taught at the Rankin County School District. Jennifer enjoys learning alongside the illustrative mathematics community as a professional learning facilitator and writer. Jennifer thinks a lot about how we might slow down and savor learning math through questions, connections, and collaboration. And so she blogs at Easing the Hurrying Syndrome and the Slow Math Movement. Jennifer, we're excited to have you with us tonight.
Thank you. I'm looking forward to being with you.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send any questions to Jill or Jennifer using the Q&A window on the right side of your screen. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate from the top of the WebEx menu and choose Audio Broadcast. At this point, Jill is going to discuss our agenda.
So as you've seen, we've done our welcome and introductions. Jennifer is going to take us through some norm setting in just a few minutes, and then we're going to concentrate on experiencing some tasks that promote reasoning and problem solving and discuss what's in principles to actions that we should be thinking and what our students should be doing to check to make sure that we are staying true to that best practice. And then at the end, we're going to talk about how to stay connected and continue this work.
Jill, thanks so much. And Jennifer is going to discuss some of our learning intentions for tonight.
Yes. Tonight we want to work within NCTM's 8 mathematics teaching practices so that we can strengthen the teaching and learning of mathematics. In particular, we will look at implement tasks that promote reasoning and problem solving. And we hope you'll take the opportunity to grow your own mathematical flexibility tonight to show what you know in more than one way in the tasks that we do.
Thanks, Jennifer. Jennifer, you should have control. Feel free to share your screen. Perfect.
All right, here we go. Even in our short time together, we want to be sure that this is a safe space to welcome both what we already know about the teaching and learning of mathematics and what we don't know yet. We are varied in our content expertise and our teaching experiences, so let's celebrate opportunities to learn from and with each other. Learning in community compels us to be brave and vulnerable, considerate and kind to each other and to our own selves as we learn and grow together. We're going to look at a few tasks, and so we'll have this opportunity to share low-fidelity prototypes of our work with each other. In language arts classes, it's common practice to share our rough draft work with each other and ask for feedback. In math classes, students are more often hesitant to share incomplete thinking. But if we practice shipping our work early and asking for feedback, then we can clarify our thinking and improve our work together. It is especially hard to practice quiet think time in a virtual setting, but we are going to ask that we take a quiet minute after we introduce each task to respect everyone's time to think quietly before immediately sharing our thoughts in the chat. Quiet think time is important for all, but particularly important for students who need a little bit more processing time, including those for whom English is a second language. We are grateful for the good work of these authors of Routines for Reasoning and how they're helping make that practice happen in many more classrooms across the country.
Jennifer and I highly suggest Routines for Reasoning if you have not read it. In addition to that, we're big fans of Susan Cain and her book, Quiet. The quick version, you can watch her TED Talk, but Quiet just gives you more details about the power of introverts in a world that can't stop talking. One of the things we've learned from Susan and the Quiet Revolution is about adding that reflective pause. And the speaker I heard talked about everyone needs that reflective pause. Introverts need to learn to think before they speak and to listen to others. We encourage our extroverts, the children who want to blurt out, just blurt by jotting it down to get your thoughts organized before you speak. And that same quiet pause gives our introverts enough time to get their thoughts organized and build their confidence so that they are ready and able to speak when it is their turn to contribute to class.
The 8 mathematics teaching practices from NCTM's Principles to Actions give teachers direction on how to plan and enact lessons. Tonight we're looking at implement tasks that promote reasoning and problem solving. But you can see that before that is number 1, establish mathematics goals to focus learning. So always important not just to do a task because it's a good task to do, but because it is a task that meets the mathematics goals that are part of the lesson. Effective teaching of mathematics engages students in solving and discussing tasks that promote mathematical reasoning and problem solving, allowing multiple entry points and varied solution strategies. So if we looked in a classroom where implement tasks that promote reasoning and problem solving was happening, what would we see? Well, according to Principles to Actions, we would see teachers posing tasks on a regular basis that require a high level of cognitive demand. I've heard some students talk about problem-solving Fridays. So this isn't just problem-solving Fridays. We're posing tasks all the time that require a high level of cognitive demand. Teachers support students in exploring tasks without taking over student thinking, allowing students to struggle productively, which connects to another one of our mathematics teaching practices. Students are making sense of problems and persevering in solving them. That might sound familiar to many of you. Students are using appropriate tools strategically. They're making use of different representations to make their thinking visible. And a norm has been established that students will use a variety of solution approaches that they will discuss and justify their strategies to one another.
So as Jennifer and I think about how we lead the teachers in our building to implement tasks that promote reasoning and problem solving, we've leveled it out this way. Well, Jill, I'm not sure that I'm implementing tasks that promote reasoning and problem solving. Well, can you empower learners in your care to make sense of tasks and persevere in solving them? Can you slow down and give them the opportunity to think and grapple and before they speak and have to answer aloud in class? Can you help them by asking clarifying questions instead of pushing them forward too fast? And have you selected a low floor, high ceiling, wide wall, open entry task that motivates students to reach for their next independent level? Have we made a pathway clear? Have we made our thinking visible without giving them do this, and then do this? So we thought we'd start with a task. This is one of my favorite tasks. In the chat, would you put what you see here? If you were to look out your window and see this, I would like to know more than it's the moon. What kind of moon is it? Thank you, Brianna. So in late elementary, early middle school science, we teach about the 8 traditional phases of the moon. So this is the one that's most recognizable by our students, and it is the full moon. So if I think about the moon, it just so happens that yesterday we had a different phase of the moon. If you looked outside yesterday, this is what you perhaps saw. In the chat, do you know what this type of moon is called? Would you think for just a minute and add in the chat what this moon phase is? Okay, you all are advanced. Most people missed this one. That's very good. This is, in fact, the new moon. And as it happens, it was the phase of the moon in the United States yesterday. And so I, as a student, well, candidly, as a teacher, I had trouble visualizing this. And so if we look and think about the Earth is revolving around the sun, and the moon is revolving around the Earth. When the moon is between the Earth and the sun, there's daylight from the sun on Earth. There is daylight on the moon, but it's on the half that we cannot see. So we see no illumination from our point on Earth. And then as the rotations all begin to occur, we see a waxing crescent, the first quarter moon, a waxing gibbous moon, a full moon, a waning gibbous, a third quarter moon, a waning crescent moon, and then a new moon. And then what happens? It begins that cycle again. New moon, waxing crescent, first quarter. Let's look at those individually, one at a time. So in a new moon, zero illumination for the moon that we can see from where we are on Earth. And then the moon continues, the illumination grows, and we see that the moon becomes a waxing crescent moon. And then it continues to become the first quarter moon. Now the vocabulary there can be tough for students if they're estimating what fraction of the moon is illuminated. It's the fraction of the moon that I can see, and so that would be half, even though we call it the first quarter moon. And then we continue, the moon continues to wax, but now it's a waxing gibbous moon. And then the moon goes to full. So all of the part of the moon that I can see from Earth is illuminated. And then the moon wanes and is gibbous. Then it becomes a third quarter or a last quarter moon. And then it continues to wane to a crescent moon. And then it becomes a new moon and begins the cycle again. At the U.S. Naval Observatory, we can actually grab data that shows the fraction of the moon illuminated for every day in 2018 or any year that we'd like. I just happen to choose 2018. So if I look at the data, can I see some repeats? I think you would agree with me that that's a lot of data to look at. So if I go back to that graphic that we were just looking at, can you think about the fraction of the moon that's illuminated that we can see from Earth as the moon phases change. Okay, so if we go, there's the data. I'm not sure we have time to input all that data. There's the source of the data. If you go to the next slide, Jennifer, we'll see there's a bit.ly there. If you would like to grab the TNS file and work with this data yourself, you can download it using that bit.ly, bit.ly 10.9.18 t cubed. Or you can just analyze this graph with me. Now recall that Jennifer said the first important thing when we implement tasks that promote reasoning and problem solving is that we know what our math or science goals are. And so I can see several opportunities here. If I'm working with 6th and 7th graders, I might want them to do, well, candidly, if I'm working with any student, I might want our students to interpret the data they see and attach meaning to the data. And so if we analyze the data, we can see that these are the days of the month with the fraction of the moon that was illuminated in August. So in the chat, can you say in August, what was the day of the full moon? Because right now the learning goal for my students is, can they attach meaning to the graph? Can they attach the science to the math? Thank you, Brianna. And Anthony, thank you. Okay, that one might have been too easy. But just to check, can you also give me the date in August of the new moon? In the chat window, can you write in the day of August of the new moon? Okay, I knew you all were advanced. This is excellent. Okay, next, I would like for you to tell me what is the date or the days that the moon was waxing. On what day or days was the moon waxing? Nice. So what we learned once somewhere was that when the moon is waxing, what is the illumination doing? Nice. I see growing and increasing. I want my students early in their mathematical careers to understand that what happens when a graph is increasing. Attach some meaning to that right there. I like to see the word increasing. Okay, can you tell me the day or days when the moon was a crescent moon? Okay, so we just said that waxing meant the illumination was increasing. Good. So I'm now looking for what does it mean for the moon to be a crescent moon? On what day or days was the moon a crescent moon? This is where the visuals of the moon can really come in handy to help learners distinguish and think about all that vocabulary visually as well as graphically. So when the moon is a crescent moon, that means that less than half of the moon is illuminated. When the moon is waxing, that means that every day the illumination is increasing. When the moon is waning, that means that every day the illumination is decreasing. And when the moon is gibbous, that means there's more than half of the moon that is illuminated. And so when we think about using this type of graph, middle school students in both math and science can attach meaning to this if we make sure that we connect the phases of the moon visually to the data the U.S. Naval Observatory offers and connect it to the graph. I will say that 2 weeks ago with our 6th graders, we actually gave them pictures of the moon for every day in a month, and we asked them to estimate the fraction that was illuminated and plot it so that they built an estimate of that graph right there by hand first by using estimation before we went to the U.S. Naval Observatory. I wonder what you think August, if this is August data, what would September's data look like? So if we change the graph so that we're graphing September's fraction, it would be similar to August, but it would have a shift of some kind. I'm seeing that in the chat. Nice. Okay, so if you're on the TI-Nspire file, you can change to the next page. We're going to change to the next slide. And you can see that in September, it follows the same pattern as August. And if I change to the next page in the Nspire document or the next slide, you can see that it has been shifted just ever so slightly. I wonder why. Why are they not identical? What would cause them not to be concurrent? Maybe I might ask, oh, very nice, some good words. The days of the number of days each month are not the same. Not every month has 30 days. Not every month has 31 days. February can just get in our way about this, for one thing. And so I like my young middle school students to see this. I like my pre-calc trig students to see this as well. How many days difference was there in the new moon of August and September? Were they a week apart? Were they a day apart? How much shift has there been over the course of 1 month? And then what I'd really like to see is if 0 on this graph is the last day of July, and so day 1 is the first day of August, day 32 would be the first day of September. What would it look like if I just continued forward? And in the Nspire document, you can see that on the next page. If we go to the next slide, we can see this is the days since July the 31st and the graph of the data in August and then September. Now, if we think about regularity in repeated reasoning, could you think for a moment? And then could you predict the date of the full moon in October? This is August and September. So do we have enough information as mathematicians to at least make a good estimate about the full moon's date in October? And when you have an estimate, will you drop it in the chat? So what day do we predict that the full moon would be in October? Okay, so I'm seeing two types of answers. I'm saying day 85, but I am really looking for October the something. So I think I would accept either one. I think October the what the might be more interesting because I'd like to show you where those beautiful moon images came from. We're going to go out to moonpage.com. And so this is tonight's moon. If you read in the small print right under the moon, at 1928:42, on Tuesday, the 9th of October, the waxing moon's phase was 0.89% full. So yesterday was a new moon. Let's check that. Jennifer, can you change that to October the 8th? And let's see if I'm right about that. And find the phase. See, yesterday was a new moon. So we just barely have that crescent illumination beginning. So I see, Jennifer, October the 24th, October the 25th, and October the 26th in the chat. Let's check October the 25th since that's in the middle. So our prediction was somewhere around the October the 25th, we should have a full moon, okay? Ooh, 98.12 or 0.12% full. So that was close. So do you think I would go to the 24th or the 26th? Do you see the reasoning and problem solving that might be here? So I see, I'd say it's about half and half. About half of you say go to the 24th, and about half of you say go to the 26th. We're going to let Jennifer decide. Pick Jennifer, the 24th or the 26th. So Jennifer picked October the 24th, and the moon is full. But let me say, I would be so happy if my students got that close in their estimate at the beginning. I will say you can spend a lot of time now checking when's the next new moon, when was the previous new moon, when is the first quarter moon going to occur next. There are lots of attaching meaning questions so that we make sure our students fully comprehend that graph before we rush to fitting the model that we might have the urge to fit.
So this particular task provides students the opportunity to look for and express regularity in repeated reasoning. My students always talked about that as finding patterns, figuring out what the patterns are. And this is a way that students can level up when they don't know where to start to figure out a pattern, but beginning to develop generalizations if they're not ready to do that yet, or even just noticing and noting what changes and what stays the same when performing calculations or interacting with geometric figures. I want us to take just a minute to look a little bit more closely at what teachers are doing and what students are doing in this classroom where implement tasks that promote reasoning and problem solving is happening. Would you take just a minute to look through these and think through what Jill just taught us, how she talked us through the phases of the moon task, and think about what opportunities you might see students engaging in some of these in that task, or the teacher engaging in some of these in the task. And we'll take just a minute to look through that and let you share some examples in the chat. And how about we agree not to just say students are persevering, period, but persevering when? At what point during that task might this happen? Mm-hmm.
So I think one of the things that students would be doing would be using the tools and representations to support their thinking. I agree with Brianna that the teachers can ask questions to unstick students when they're confused. I do find that my students are great with the science teacher about wax and grain and crescent and gibbous, but when asked to transfer that knowledge over to the graphical, more abstract representation, they really then begin to struggle with interpretation of less than half, more than half, and which one is the first quarter and which one is the last quarter. So I do agree with Brianna that asking those unsticking questions is really important. I think using both the images of the moon and the graphing technology are good tools to connect those representations.
All right, we're going to continue to think about implement tasks that promote reasoning and problem solving. Thank you for thinking through what teachers and students are doing during that task with us. We're going to switch gears just a little bit. We want to spend a little bit of time thinking about look for and make use of structure. I think this would be my favorite math practice, and perhaps my students as well. So if you're not ready yet to look for and make use of structure, then can you rewrite an expression into an equivalent form? Can you draw an auxiliary line or identify a pattern? My students and I actually use this mantra. What can you make visible that isn't in the picture yet? Can you compose and decompose numbers and expressions and figures to make sense of the parts and of the whole? So we've heard Magdalene Lampert and Amy Lucenta and Grace Kilmanick talk about this as contemplate, then calculate. We've heard Gail Burrell talk about it as look before you leap. And Jules Bonin-Descharmes talked about it as visualize, then verbalize, then verify. So we're going to look at just a very brief task that provides an opportunity to look for and make use of structure. Take just 30 seconds of quiet think time before you say anything in the chat. Okay, will you make your thinking visible in the chat for us? What are you thinking? What do you see?
I see
So
what
the Pythagorean theorem. I'm seeing 16 square centimeters or 16 centimeters squared. So lots of opportunity there to make sense of the units. So this one was an opportunity to think about looking for and making use of structure. What we're going to do next is actually go look at a couple of tasks. And we're going to think about the task and how the task analysis guide might help us ensure that we are implementing tasks that promote reasoning and problem solving. So if you would go to this bit.ly that's here, I think Jill can put it in the chat for us, or Mike can do that, so that you'll have a direct link to it. But this bit.ly T310918 will take us to a Google Doc that has a couple of tasks on it, and it has a link to the task analysis guide as well. So I'm going to give you just a minute to make sure you can get there.
I did drop it in the chat.
Okay, great. All right, so I have just 3 tasks here. They're just numbered 1, 2, and 3. And I think that what we should do first is spend a few minutes actually looking at the task analysis guide. Some of you might be familiar with this from reading the 5 practices or from looking at taking action by NCTM. But if you click on that top link, then that will take you to the task analysis guide. And this was just one that I found on the NCTM conference site, a copy of it that I found there. So I want you to take a couple of minutes, and it's going to be a little quiet for a minute while you do this, but I want you to just look through, even if you've seen this before, take another minute to read back through each of these categories: memorization, lower level demand, or procedures without connections, or the 2 under higher level demands, procedures with connections in doing mathematics. Let's take a minute just to read through those, and then we'll go look back at those 3 tasks and see what we think about which ones might be in which category. Okay, so this is going to take a little negotiating, but let's be patient with each other and do the negotiating, because I think the conversation is worth having. So in one window, you might want to keep open this task analysis guide, and if you haven't clicked anywhere to find it, you can just do a quick Google search for the task analysis guide, and this one from NCTM will likely come up first. Then we're going to look at these 3 tasks. And we're just going to call them number 1, number 2, and number 3. And so as you begin to look at these 3 tasks, let's generate some conversation in the chat about which task we think might go with which category and why we might categorize it that way. What is it about that category that makes you think this task would go there? Okay, I'm going to take just another minute for you to put some thoughts into the chat about task 1, task 2, or task 3, and which category you think it might be and why, and then we'll have some conversation about that together. Okay, so just looking at task number 1 for just a minute. That was the first one that we did. We have somebody who's saying that that one is memorization because it's involving previously learned facts. You're reproducing those previously learned facts. We have somebody else who suggests that number 1 is procedures with connections, because of having a conceptual understanding of the Pythagorean theorem that's needed in order to solve it. So one nuance that I think might come into play here is how have students been taught the Pythagorean theorem? Have students already seen a problem like this before? Or is this brand new? Have they just solved regular right triangles where they've been given 2 of the side lengths of a right triangle and they're asked to find the third? Does this require something different from that particular procedure? And then one other thing that I've wondered about is, even in the same class, even if students have been, worked through the same activities before, had that same level of conceptual understanding, could the way that a student approaches a task mean that they're going to, one of them might be doing it as procedures without connections, and one of them might be doing it as procedures with connections? Or based on that student's prior knowledge, might some students be doing procedures with connections while another student is actually doing mathematics? So I think that's are just really interesting. I'm not sure that we have to come to consensus on which one falls with which, but I think these are good conversations for us to have with our coworkers and for us to think through that over the course of a unit, are we providing our students the opportunity to engage in high cognitive tasks and not just procedures without connections the whole time or memorization? How can we get to those higher level demands? So great. Thank you so much for negotiating all of the tabs that you have to have open for that. All right, so we are going to go to another task now.
So think about what we just talked about low-level demand tasks and high-level demand tasks, and look for and make use of structure. And can you take just a second and evaluate that for me? 21 squared minus 19 squared. Think for just a minute. And in the chat, will you not only tell me what 21 squared minus 19 squared is when you evaluate it, but how you evaluated it? Okay, for those of you using a calculator, let's try it again and think about how you might reason and problem solve and not go straight to a tool. Since you know the solution now, the value of 21 squared minus 19 squared, can you exercise your mathematical flexibility to show how you know more than one way? So yay, you have the answer from the calculator. How else might you show that? Oh, I begin to see some connections. I know that I've seen some of you write in here, this is procedures without connections. But I think I might begin to see some connections here with at least some words around how to create a visual model. You may not know, but right now I serve as the Director of Teaching and Learning in an independent school that is strictly an elementary school and an early childhood center. And I have learned more math. I was an AP Calculus teacher, an Algebra 2 teacher, a Pre-Calc teacher, and an Algebra 1 teacher. They let me teach geometry twice in my career. I have learned more math in the last 6 years than I think that I knew before, because I've been teaching our teachers to connect visual representations with algebraic procedures. Another one of the math teaching practices is to build procedural fluency from conceptual understanding. So I'm hoping that we stop and think about, look for, and make use of structure to recognize that, oh, I could square 21, I could square 19, and then I could subtract them. That is one way to go. I could use a calculator. That's another way to go. But I also see there the difference of squares, right? Which tells me that that connects to x squared minus y squared, or a squared minus b squared. So another way to go, which I did see in the chat, is to say 21 minus 19 times 21 plus 19. But not all of my students recognize that. Even as the AP Calculus teacher, not always did my students recognize when I had the difference of perfect squares, which makes me wonder, what could we have done earlier in Algebra 1 even to deepen their conceptual understanding? And here's what I know. When we teach multiplication in second grade and third grade, we build arrays and area models. So I asked myself, what would this look like if I know that 21 squared minus 19 squared, can I draw that? And can I also illustrate the difference of two squares? Because what that tells me, the difference of two squares tells me that that is equal to the quantity 21 minus 19 times the quantity 21 plus 19, which is 2 times 40, which is 80. Okay, so if I go to the next slide, I always try to back down to simpler things when I draw. And forgive me, I was having a stream of consciousness, so you have to read from top to bottom. If I have 2 squared minus 1 squared, you can see 2 squared, and then I've put the 1 squared in the lower right-hand corner, and then I've removed it. And I noticed that I could move that 1 square up to create that rectangle, and the shape of that rectangle, I've decomposed that into a rectangle. I've decomposed and recomposed it into a rectangle that is 3 by 1. If I look at 3 squared minus 1 squared, I can see the 1 squared is removed, and that I have a 1 by 2 that I can rotate, move over, and it creates a 3 by 2 rectangle. And I thought, okay, I'll test it with 3 squared minus 2 squared, and then 5 squared minus 3 squared. If we take the time, you know, Joe Bowler talks about visual math quite a bit. If we take the time to build a visual understanding of this and connect, the difference of these two squares makes this picture. And every single time I can decompose and recompose it into a rectangle, which is a multiplication problem, and oh, there's a pattern to that multiplication problem. Look what the pattern is. It is the sum of the two bases times the difference of the two bases. Then maybe we're giving more students access to even factoring it when it becomes x squared minus y squared, 4x squared minus 25y squared. Maybe by laying that foundation of connecting it all the way back to second and third grade math. And in sixth grade, when we find the areas of irregular shapes, if we connect all of those opportunities to our students, maybe we're giving them the opportunity to build procedural fluency from a visual conceptual understanding, which I think moves that into the higher level demand, and it's a task that promotes reasoning and problem solving. At Trinity, at the elementary school, we continuously stay in dialogue with our parents that we are not looking for an answer. An answer is a step in the right direction, but we want mathematical communicators who can show what they know more than one way, and they can show their work and thinking so that a reader understands without having to ask them questions. Because we feel that that's what's setting our students up for success when they get to algebra, pre-calc, and calculus, if they have that deep conceptual understanding and they communicate at a high level. They have more to hang their hat on when they're trying to anchor new thinking.
All right, so we're not going to have time to work through this task, but we just wanted to include another opportunity to look for and make use of structure. This is called a cubic identity. It's one of the tasks from illustrative mathematics, where you can find lots of good tasks that provide students the opportunity to meet those higher cognitive level demands of procedures with connections and doing mathematics.
And I want to add that at Trinity, we actually tackled this task and connected it to what we teach our 4th, 5th, and 6th graders about multiplication of two-digit numbers, about long division, and about ratios and proportional reasoning. So while everybody kind of freaked out about all the letters flying around because we don't do much with variables at the elementary school, I could connect this to here's what you're teaching and why it's so important that our students understand this with numbers, because the same thing's going to hit them later in both math and science, but it's going to be more generalized. And so again, we worked on connecting back to prior knowledge or helping our teachers connect to where students are going later. So if you haven't read the 5 practices, the Smith and Stein's 5 practices are very important for high-functioning teams. But as we talked about at the beginning in principles to actions, I can determine mathematical goals to focus learning is first for a reason. First, we have to know what the expected or intended outcomes are for our students, and then knowing what the learning goals are. Then we select those high-level demand tasks so that we can promote reasoning and problem solving for the learning that is necessary and appropriate for the course that we're teaching. We want to intentionally select those high cognitive demand tasks to forward the learning goals for our students and the course that we teach. So if you've not read the 5 practices for math or for science, we highly recommend that as a part of our reading list as well.
All right, so before we hand this over to Mike, we want to take just a minute for us to think about our own learning tonight. David Sousa and How the Brain Learns Mathematics says that closure in a learning episode doesn't need to be packing up your things or closing out of your browser. It should be an actual cognitive task, thinking about what you've learned, how it's connected to what you're already doing, and what you will be doing. And so would you take just a moment to think to yourself, is there something that you learned to pay attention to tonight, or something that you might begin to ask yourself? Or is there a new mathematical connection that you have made tonight? And if you want to share that in the chat with us, we would love to hear from you, but we'll also understand if you would like to just keep that thought to yourself.
Mike?
Thanks so much, Jill and Jennifer. As we wrap things up tonight, we do want to share a few things that are going on. First is that we're excited to have the T-Cube International Conference coming to Baltimore this coming March. If I had to guess, I bet that both Jill and Jennifer are going to be there, and even more of a better guess is that they're probably going to be presenting at least a session or 2 or 3 or 4. They're usually pretty busy. So please feel free to join us at the International Conference and find Jill and Jennifer, attend their sessions, and get a chance to actually meet them face-to-face. We're excited to be starting a new promotion. It's going to be called the TI Extra Credit Contest. You can learn more at TIExtracredit.com. And by doing things that you probably do already, like, for instance, attending this webinar, you will earn entries. And for each entry, it gives you the chance to win certain prizes. So a few things. So, for instance, tonight's webinar, every time you attend a Tuesday webinar, you can that's worth 5 entries. And then each webinar this fall, we're going to be giving away a special bonus code that you can use to gain additional entries. So the non-case sensitive code for tonight is Show What You Know. Again, that's SHOW-WHATYOUKNOW, Show What You Know. And that's worth an additional 10 points. So feel free to visit TIExtracredit.com to learn a little bit more. To receive a certificate of attendance, go ahead and click the link that's coming up in the chat window. Also listed as a link for the documents from tonight. I'm going to be updating the documents link in a couple of days, so feel free to download the documents link tonight, but in a couple of days you'll actually get a follow-up email. In that follow-up email will be a link to the recording, a link to the documents, and a link to the certificate as well. The update documents link will contain all the slides that Jill and Jennifer are using from tonight. So feel free to download it now, but know that you'll get an updated link in your email in a couple days. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Thanks so much, Jill and Jennifer, for everything you shared tonight. I really appreciate it.
It was fun.
Yes, we enjoyed it. Thank you, Mike.
And thanks again to everyone for joining us. We hope to see you back online real soon. Have a great night.